Okay, Biology B students, here we go. Lesson 1.3, Population Ecology. And we'll look at some of the different things that determine populations, population growth, and all those good things. So all the individuals of a species that live together in an area, that is what a population is. So it could be a population of bluegills in a pond, a population of Canada geese behind the schools, that type of thing. And then we have the thing, a term called demography. And demography is the statistical study of populations and allows predictions to be made about how a population will change. So very important thing of demography is in the advertising world where you have a product and you try to figure out which show should I put my commercial on? Should it be a Monday Night Football, or should it be on National Geographic commercial for doing that? What population of people are watching those shows where my product will get the most bang for their buck? So you study the demography, is it 18 to 24-year-old males, something like that. So population dynamics, there's three different things that we have to pay attention to. The size of the population, how dense it is, which is very interesting with this COVID virus, and dispersion, where are they? So as we go about and study these populations, we'll look at these three big points. So the size is the number of individuals in the area. And then we have to look at things like growth rate, which is your birth rate minus your death rate. You look at how many individuals are born versus how many are dying. Birth rate minus the death rate equals your natural rate of increase of the population. And so are they doubling their population? Are they maintaining the same population each generation? Or are they decreasing? So we looked at these last time. Again, on the bottom, you can see the numbers 0 to 8. That is the percentage of the population of that particular age group. So 0 to 4-year-olds and 5 to 9-year-olds in the Kenya growth rate are the most, is the largest population of people. So if you look at that country, it's very, very young in general. And then due to a host of different reasons, they just don't live very long. If you look at the slow growth rate, like the United States, a good portion of the population is somewhere between that 0 to 4% of the entire population, where you have a few larger bumps around 30 to 34 and 35 to 39, somewhere in there, in those years that they were born. It was a very interesting time. And then you look at the zero growth decrease, all right, where there's not as many younger people, where the population is not having basically replacing itself. And so you wind up having zero or a decrease in the population. So that's a good example of looking at a population and size per age group. Three key features of populations: the density, measurement of a population per unit area of unit volume. So it's basically the number of peoples in the given number of space. So if you look at some place like Beijing, New York City, places where there's a lot of people in a little amount of space, I think something like COVID can spread a lot faster than people that are out and not densely populated and close where they can spread it faster. How do you affect the density? A couple different things. You have people that are coming into your city or your country. All right, so you're allowing more and more people each year. The United States has a pretty good immigration policy. And although our birth rate is decreasing, we have enough people coming in each year where our population is still growing slowly. Emigration is how many are leaving. Could be leaving because of a job, for whatever, disease, war, whatever it might be, but people leaving will affect the total population numbers. And then density dependent factors, biotic factors in an environment that have an increasing effect as a population size increases. Disease, competition, parasites. So as population starts to increase in the forest, there's a lot of deer, they're going to be competing for the small amount of food resources and potentially do enough damage to the ecology that it can't support very many deer at all. Density independent factors, abiotic factors in the environment. These are non-living factors that affect the population. So for example, the fires out in California is a great example in abiotic factors that affect the population's density, temperature, weather, some others. Okay, so the factors that affect the future population growth, you can see all these things having a role. How many are born, how many die, how many come in, how many leave. This is the dispersion pictures, right? If you look at the dispersion, the clumped version, you have a lot in one area and then not many in other areas. So it could be something to that effect. That's what clumped is. You have a uniform distribution, so they're evenly spread out throughout the entire area. And then you can have random, where there are some here, some there, and that kind of thing. So 3 key features, again, of these dispersional factors on a population: the clump, uniform, and random. Population density is equal to the number of individuals in a given area. Count all the individuals in the population, estimate by sampling. So here's one particular tool, say for in Ohio. Each year we have to determine how many deer a hunter is allowed to capture or kill, for their own use. So they have to determine, okay, where's the deer population? Is it large or is it small? Do we need to kill a few more this year to keep the population down, or do we need to not kill as many because the population is low? We need to increase the numbers. And so one of the tools is this mark and recapture. So they'll go out in the woods and they'll try to capture deer and put a tag on their ear, and then they'll go away for a couple months or a year, and they'll come back and they'll try to recapture and see how many of the ones they recapture have that tag on. If they capture a lot with the tag on, that means the population is very small. If they hardly capture any that have the tag on, that means the population is large, and they can decide accordingly. How do populations grow? There's a couple different ways, but one of them is called exponential growth. If you look at the human population and how it has grown over time, it was very slow for a long period of time. And then in the late 1800s and on, it just started to do that, explode. So we were going, doubling our population. It took many years, and all of a sudden we were doubling our population within 12 years. So that's exponential growth. It's just slow, and then all of a sudden it explodes. And then we have a logistical growth, which is a little more regular. So carrying capacity is a way in which we can look at an ecology of an area and determine how many individuals can live in that area, how much food is there to support them, how much shelter is there for them to live in, that type of thing. If you look at a pond, there's only so much food in there, and it can only support so many fish. So, once you go above the carrying capacity of an ecosystem, of a pond, then the population tends to slow down. It won't grow as fast, or it could crash. So maximum population size that can be supported by the available resources. There can only be as many organisms or individuals as the environmental resources can support. So here's a good example of that slow growth, and then all of a sudden it just explodes. It's exponential. Logistical tends to grow at a moderate pace until it reaches, if you think of that term we just talked about, this is that carrying capacity, right? Anytime you tend to come near that carrying capacity, you might go over it, and then it'll go down. It'll tend to stay right around this area, because that's all the food or resources that you have to support a certain population. In this case, it's fur seals. Some limiting factors. Declining birth rate or increasing death rate are caused by several factors. Limited food, toxic waste. If you think of a fish tank where you have a lot of fish in it, and you just keep having more and more fish, well, sooner or later the filter can't keep up and develop a toxic waste, and that'll kill the population. Disease, and then predation. Those are all things that will help limit the size of a population. We have some natural cycles. This is called the boom and the bust. Snowshoe hare And the lynx is a population that's been studied for a long time. And if you follow the picture here, the snowshoe hare population, say in 1850, starts to grow and explode, right? Well, at the same time, the lynx population wasn't very large. But since the population of snow hare grow, the lynx population has more food to eat, and therefore their population becomes healthier. Their offspring have more food to eat. Their parents have more food to eat. They will have more children. The children will live. And so their population explodes. Once that happens, they eat too many snowshoe hare, and then you can see the snowshoe hare population crashes, and then soon after, the lynx population crashes. So this goes on and on all the time. So it's either going up or going down. Some different types of strategies for reproduction. We have the R strategists. These are individuals that will have a very short lifespan, very small, reproduce really quickly, have a ton of young. There's not much parental care at all. You can basically lay eggs and leave them alone. So cockroaches, weeds, bacteria, things like this just grow at an alarming rate, but they don't live very long. Or you have this K strategist, which is a long lifespan. You know, a lot of these animals will have a baby, and that baby will not be able to reproduce for 10 years, 15 years, whatever, some not long time. They'll be large in body size, they grow very slowly, have very few young. The parent tends to take care of them, right? So that's a slow growth K strategist. So you have these two different strategies of growth. Age distribution, number of males, number of females in each of the group's population used to predict future growth. So if you don't have a ton of females, then you're not going to have a lot of offspring. So the baby boom age group, when they wound up reaching the ability to have children, that's where we had a little bit of a bump. And that's all changed now as things are starting to slow down there as they age out. Okay, so the human population growth was looked at as a J curve. It grows at a rate of about 80 million yearly. Why doesn't environmental resistance take effect? Altering their environment, we now are able to grow way more crops on an acre than we ever have before, so we have enough food. Technology advances, whether it be in the medical field, healthcare, a lot of different ways. So we have a lot of ways in which we can keep the population healthy. But there is a limit. Doubled 3 times in the last 3 centuries, about 6.1 billion, and may reach 9.3 billion. Right now, we're currently sitting at about 7.5 maybe. Improved health and technology have lowered the death rate, so the population just grows. This is our growth rate for the humans. You can see a little dip where we had the plague, but again, for the most part, within the last 10 decades, 100 years or so, we've really exploded. And that is the lesson.